Thank you, Bill. Thank you for the invitation to be speaking today. I think my disclosures here are surgical management systems. So when we're speaking about synthesizing data, I think when it comes to implant surgery, the first thing to think of is the surgically induced astigmatism vector, or the SIA, because this gives you the total astigmatic effect of the incision. But the SIA has some variability, and we need to take this into account. So the SIA gives you the total change, but when it is a little bit offline from the incision, it really has two components. It's the flattening effect, which is the effect of the SIA in the direction of the incision, and then there's also the torque effect, which is actually what actually rotates the astigmatism and doesn't reduce the astigmatism at all. And so when there is any amount of SIA being off axis from the incision, in fact, the flattening effect, which is actually the amount to reduce the astigmatism, is less than the SIA. So the SIA is an overstatement of the amount of change. Not only that, when you calculate the flattening effect, the astigmatically active incision is most active when it's operating on the steep meridian in a study we published in the JRS just in 2016. And so you get quite a lot of change when you operate on the steep meridian, whereas when you operate on the flat meridian, wherever it might be, you actually get a lot less change and it's much more astigmatically neutral. The other variable of the SIA is shown by Su Cheng from Shanghai, and what she showed is as the astigmatism increases, so does the SIA, almost greater than a factor of 1 in 3. For every diopter, you get more than a third of a diopter increase in the SIA. So the SIA is quite a variable figure. So in our study, we showed over 1,300 eyes of 650 patients on left and right eyes. The flattening effect on the two eyes was significantly different, which is interesting when you have the same surgeon, right-handed surgeon. Obviously showed some more reliability in the right eye with the right-handed surgeon than the left eye. But when you look at the actual SIA, the figure was 0.64, which is quite a big number for incisions that are 2.2 millimeters using a diamond blade. So when you look at a whole eye from, when you put incisions on axis as we have here, you can't use a summated vector mean because of the variable incision sizes, but you can use the flattening effect, which effectively is a summated vector mean at each side of the incision. So to use the Alcon toric calculator as an example, it recommends that you can use an incision that's less than 2.5 millimeters, you can use 0.1 as an incisional effect for all your incisions. So really, in this case, the SIA is not real, as I just showed you. It's probably around, for a 2.2 incision, it's up to 0.6 millimeter. Flattening effect is around 0.3. It's still 3 times as much as this. So it's really a contrived number. It's not a real number that you use when you just use 0.1 for everything. You might as well just use a 0. So when you look at the simulated keratometry, or the SIMK, it's dependent only on one ring at the 3 millimeter zone, which can have some variability when there's any irregularity. So when I looked at this a few years ago, I decided, why not use all the rings of a topographer or a tomographer, and by taking a vectorial average of them, if there is any irregularity in any one ring, it gets washed out by having the average of them all. So in an ideal world, using the gold standard of the refractive cylinder of the corneal plane, because that goes all the way from the front of the eye all the way to the perceptual component in the brain, in an ideal world, all the K readings will be exactly the same as the R. But of course, that is an unreal expectation. So when you look at the idea is whatever K reading is closest to the manifest refractive cylinder is probably going to be the best representation of the corneal astigmatism. So in 2012, we published in the JCRS Corneal Topographic Astigmatism, or CorT anterior, looking at the anterior only, and that was closer than SIMK and all the automated keratometry values. And then when in 2015, when we published in the JS the CorT total, it was even closer again. So this year we're going to have in the next month or two, this is the galley proof, an article where we compared CorT total to 3 of the major topographers, And really, when you look at them all, the benchmark is the CorT, which is closest to the best of two of them and better than the third. So we have provided on the ISR website, free to all ISRS members, a number of calculators that you can use when you're doing analyses. So looking at looking at the group analysis calculator, you can now do analyses at no charge. It's a free calculator for refractive, corneal, but particularly toric implants. And with toric implants, this is going to give you analysis of the whole implant. Is the implant toricity on axis or off axis? Is it overcorrecting or undercorrecting? And in particular, we also provide a basic calculator which just compares post-op and pre-op calculations, which, when you look at it, is just a comparison of magnitudes in whichever way you do it. And it cannot really stand alone as an analysis component. It needs to have a full toric analysis. Then the toric calculator that we have has the anterior cornea, but it also has the total corneal astigmatism, whether it be CorT or the total corneal power from one of your tomographers. And then you can have this is on the website also, you can have every implant available and pick out the ones that you like. Say if you have 2 or 3 favorites, the one that has the spherocylindrical component closest to 0. So for example, if you have a refraction, you can step it up and step it down. So if that's 0.49 with 0.75 steps of implant, if you step it up to 4.5 diopters, it's much less, down to 0.05, so that would be your choice. And if you want to know more about this kind of toric IOLs and CorT, you'll see in my book, in those 2 chapters. In summary, use calculated flattening effect, not SIA, because for SIA, for 2.2 mm incisions, it's more accurate, the flattening effect, than SIA. CorT total is more accurate than an estimate. CorT total uses all the calculated data from the corneal power, and CorT total, or total corneal power, is for toric planning for more accurate measures. Thank you.